Welcome to Chapter 6, Number Patterns and Recursions. Starting with 6.1, Arithmetic Sequences. Our learning intention: what are arithmetic sequences and how can we graph it? Success criteria: I can define and identify AS, or in this case, arithmetic sequences. And I can find the common difference from the arithmetic sequence. So AS will be the shorthand for arithmetic sequences. I wanted to save a little bit of room on these PowerPoints and I got a little bit lazy with my typing. What are arithmetic sequences? A sequence is a list of numbers in a certain order. The numbers in a sequence are called the terms. An arithmetic sequence is a sequence of numbers that has a starting term and is formed by adding or subtracting a constant number to each preceding term. This constant is called the common difference and is denoted by the symbol D. All right, a lot of words. Let's break this down. First of all, I'm going to pop a list of numbers. 3, 5, 7, 9, 11, 13. List of numbers. This list of numbers is called a sequence. So a sequence is a list of numbers in a certain order. I've got my numbers there. They're in a certain order. They're starting with a lower number, increasing up to by 2 from 3 to 13. The numbers in the sequence are called the terms. So this is my first term. These are my terms. This is my first term, my second term, my third term, fourth term, and so on and so forth. So we've defined that. That's a term. An arithmetic sequence is a sequence of numbers that has a starting term. All right, I'm going to change colours here. I have a starting term, that's my first number. It's denoted by either T1 or A. So term 1 or A as my starting number. Or my initial term. And is formed by adding or subtracting a constant number to each preceding term, so the number before it. This constant is called the common difference and is denoted by the symbol D. All right, so how do we get from 3 to 5? We add 2. How do we get from 5 to 7? We add 2. 7 to 9, we add 2. So the common difference in this case, my D is equal to 2. So being that I've now got an A value and a D value, any arithmetic sequence, I can find the nth term. So for example, if I want the 25th number in that sequence, I can find it because I've got my initial term or my starting term and I've got my common difference. All right, example time. For the arithmetic sequence 5, 8, 11, 14, it's asking us to find D, T1, T2, T3, T4, etc. I'm going to start with T1 and skip D for now. T1 is my A value. It's the very first term and it's the number 5. It's the first term, in the sequence. T2 is my second term. In this case, it's the number 8. As you can see, I've got the little t there. I'm after my second term, T2. T3, there's a 3 there, is the third term. And we count 1, 2, 3. So my third term is 11. The fourth, using the same method, is 14. This is all on page 258 of your textbook, if you're following along. Now to find my D value, I can go, all right, let's change colours on this. 5 to 8, I know it's plus 3. 8 to 11, I know it's plus 3. I know that my D value is plus 3. There's actually a way to go about it. Sometimes you might not know what the exact number is just by looking at it. So we have to use a formula. We take our second term and subtract our first term. In this case, it's 8 take 5, giving us 3. If we don't want to use the first and second terms, we can use the third and fourth terms. It doesn't make a difference. Let's have a look. T4 take T3 equals 14, take 11, still gives us 3. Because it's the common difference and it's a constant, it's going to be whether you use the 25th and the 26th terms, it's going to be the same D value through the entire relation or the entire sequence. So the notes at the bottom, the common difference, D equals any term minus its previous term. T2 take T1, T3 take T2, or T4 take T3. All you need to generate an arithmetic sequence is the first term A and the common difference D. So graphing arithmetic sequences. We can continue the arithmetic sequence 5, 8, 11, 14 and make a table of values for n, the number of the term, and t of n, the term. So the first number is 5. That's where our n value is 1. Second number is, second term is 8. The n value is 2. Third term is 11 and the n value is 3. Up to, in this case, up to 7. So when we're graphing, we graph this table, this particular table, or any of the arithmetic sequences tables, with n on the horizontal and our t of n on the vertical. Remembering from chapters 4 and 5, your n, this is your independent, or your explanatory. And this is your dependent or your response variable. Now, the graph follows a straight line. So arithmetic sequences are linear. They are a straight line. The slope for this particular line is 3. That's my D value. So the slope of the line equals D. For every one n value we move to the right, it goes up by 3. So the slope is D, which is my common difference. So if in any questions or any assessments it asks you for the slope of the arithmetic graph, you look at it and go, okay, what's my common difference? I can tell you what the slope is. So if the slope of the line is, if the common difference is positive, then the slope of the line is positive. So we've got a positive D value. We'll change colours. If the D value or if the slope of the line was negative, it would indicate I've got a negative D value. So the graph of an arithmetic sequence always has the points in a straight line with the slope equal to the common difference. All right, the rule for the nth term of an arithmetic sequence. Looking at the following pattern lets us find the rule for the nth term of an arithmetic sequence, where T1 is the first term. So if you're looking at your textbook, you can find this on page 259. I've deleted it from the slide here just to show you how it works and how it increases. So narrow my pen a bit. So in this case, I know that my D value equals 3. And on the top one, I'm just going to call D, D. On the right-hand side, I'm going to keep D as D. On the left one, D is 3. So my T2 value is 5 plus D, which is 3. I'm not going to solve this. I'm going to leave it as 5 plus 3. And my T2 value is A plus D. We know that. We can see 5 plus 3 is 8. 5 plus 3 equals 8. Yep, looks right. My T3 value is still my initial 5 plus 3. Then it's another 3. So I've now got 2 3s. And on the right hand side, I'm going to put in, keep my A plus D. So each time remembering that we're just adding another D value to it. Plus another D gives me A plus 2D. T4 continues along. So at the moment I've got 5 plus 3 plus 3. I'm keeping them all as 3s. I'm not simplifying anything. And I'm going to add another 3. And I'm suddenly up to 1, 2, 3 3s. I've got my 5 plus 3 times 3. We'll do the same thing across in the A and D columns. A plus D plus D. Then we'll add another D, giving me 1, 2, 3 Ds. And T5. 5 plus 3 plus 3 plus 3. 1, 2, 3, yep. And add my fourth 3 is equal to 1, 2, 3, 4. So 5 plus 4 times 3. And in A and D form, T4, scribble that out. We need T5 is equal to A plus D plus D plus D. That's our T4 value. Plus another D. If we count them, we've got 1, 2, 3, 4. A plus 4D. Now we're going to jump to T of 20. Using this same formula, we can see when we had T of 5, we had times 4. When we had T of 4, we had times 3. When we had T of 3, we had times 2. So T of 20 is going to be 5 plus 1 less than 20 is 19 times 3. And T of 20 on this side is equal to, so we've got T of 5 on the right, and it's 4D. We've got T of 4 and 3D, T of 3 and 2D. So it is 1 less than what your n value is. In this case, A plus 19, because we're looking at T of 20, times D. From that, we can formulate the rule. Grab a highlighter. T of n equals A plus n minus 1D. So if you wanted the 45th n value, or the 45th term, you'd put T of 45 equals your A value plus 44, because it's 1 less than 45, times your D value. So the rule for the nth term, T of n, of an arithmetic sequence is T of n is equal to A plus n minus 1D, where T of 1 equals A equals the first term, and D is the common difference. All right, my apologies for the squished up picture. It didn't convert too well, but I will read it out to you. If the first 6 terms of a sequence are 2, 7, 12, 17, 22, 27, state the value of the 10th term and the 20th term of the sequence. So this is worked example 1 in your textbook. It is found on page 260. So this is clearly an arithmetic sequence. Identify A, the first term, T1, and D, the common difference. And change colours. So this is my first term. So A equals 2. And then my D is, that's my T1, that's my T2. T2 subtract T1, giving me 7 take 2 equals 5. So my D value is 5. Use the formula T of n use the formula T of n is equal to A plus n minus 1D to find T10 and T20. All right. T of n is equal to, let's substitute these in, A plus n minus 1D equals 2 plus n minus 1 times, what's my D value, is 5. So, T of 10. Remember 10, you know what, I'm going to get rid of that one, equals 2 plus 10 minus 1 times 5. We'll do it like this, 2 plus 9 times 5, 2 plus 45 equals 47. So that's my T of 10. Now my T of 20, I'll do the same way. I'm going to change colour so you can see the difference between the two. T of 20 equals 2 plus 20 minus 1 times 5. 2 plus 19 times 5. 2 plus 95 equals 97. Pretty straightforward. All I did was I substituted my n value, in there. Why is this not working? Let's just draw a big circle over it in green. Put my n value there, put my n value there, and solved. Put my n value there, and solved. Worked example 2, which is also on page 260. So, Sue borrows $5,000 from an unauthorised broker and is unable to pay it back. After missing her first payment, she is charged another $3,000. Far out. For every subsequent month, she is unable to pay anything towards her debt. How much does Sue owe after 6 months if she continues to be able to pay it back? So, question 1. Use the arithmetic, or point 1, use the arithmetic sequence 5,000, 8,000, 11,000 and the formula to find T6. So she starts off with 5,000. What am I doing? I don't even know. There we go. She starts off with 5,000. That's my T1 or my A value. Then every month she adds another 3,000. This is where we're getting all this information here. Adds another 3,000, that's 1 month. Adds another 3,000, it's 2 months, etc. So we've got our A value of 5,000. And my D value from the information above was 3,000. I need to find my T6 value, so I substitute it into the formula. T of n equals 5,000 plus n take 1, 3,000. And I want T of 6 equals plus 6 take 1, 3,000. Keep simplifying, plus 6 take 1 is 5 times 3,000. 5,000 plus 15,000 equals 20,000. So in 6 months, she borrowed 5,000. If she can't pay it back, she has to pay another $3,000. That's pretty steep. So in this case, after 6 months, if she's unable to pay it back, she suddenly owes $20,000. So that is arithmetic sequences.